Fun on the morning show at 13 minutes before the hour. Wise Guy Wednesday.
Our favorite mad scientist, Matt Selen, is live in his lab this morning for an experiment that's really going to get us going. We're talking about engines this morning.
That's right. Hi, Gay. Hi, Matt. How are you this morning?
We're fine. What do you have cooking there in the lab, so to speak?
Well, you might hear a kind of a funny sound, and if you have a look at it, what I have here is a steam engine. Actually, my question last week was, how does a steam engine work? And I got two wonderful answers from Alicia in Thawville and Adam in Effingham, and so they have T-shirts right now. And so here we have a steam engine that's operating, and all engines basically work on the principle that you have an expanding gas or a high-pressure gas that pushes a piston. And what happens here is that there's a little piston that pushes this inside here that gets pushed down, and it makes the wheel turn, and the thing just kind of keeps going round and round as more and more high-pressure gas gets ejected at just the right time. It shoves the piston down, the wheel turns around, it shoves the piston down and again, and away it goes. And I had one of these when I was a kid, actually, where you actually lit a little fire underneath it, and it was very cool. This thing runs on electricity to heat the water. If you look at the end here, there's actually water boiling inside this thing. And so that's how a steam engine works. You have water, you heat it up, it boils, it turns into high-pressure steam, and that steam is used to push this piston. And so various engines just have various ways of producing high-pressure gas. So it's too bad Robert's not there, because I know he likes liquid nitrogen, but this thing runs on liquid nitrogen, because that's very easy to boil. I can pour that into this brass container here, and I simply put on this lid, and now the liquid nitrogen boils. As we've seen before, when liquid nitrogen boils, it basically expands. You have a lot of pressure coming out of it, and we blew up bottles and things in the past with that, and we can also use it to drive an engine. So here the pistons are on either side, so you can see that an expanding gas is driving those pistons, and that's pretty cool, so I'll turn that off. There's something else which is very, very interesting, which is called a Stirling engine, which is what I have right here. A Stirling engine is special in that you provide the heat basically on the outside of it, as I'm about to do here, and all the gases and things that do the expanding and contracting and pushing on the pistons are inside the engine itself, and they never get out. So these things are very, very clean, and they tend to be very efficient. So all I have to do is heat the outside here, and we'll see that this little thing starts to turn in a moment. And the last thing I'm going to show you is a very special little Stirling engine which operates on very small temperature differences. Here I have a hot plate which isn't very hot. I can put my hand on it. All I do is put my little propeller guy on there and just give him a turn, and away he goes. So these Stirling engines are kind of fascinating. All the gases that expand and contract are inside. They're trapped. They never get out, and all you have to do is provide a heat source on one side and something cool on the other side. So in the case of this little engine right here, okay, we have hot here, cold over here. Here we have hot plate and cold on the top. Okay, so I'm probably out of time, but that's the engines that we're talking about at the beginning, and in the second segment we're going to talk about thermoelectricity.
Okay, well, I'm fascinated. We're sitting here watching these with fascination. This is great.
With something like liquid nitrogen, could that be applied on a greater scale, or is liquid nitrogen not cost-effective, where you might be able to use it in cars or something?
Oh, it wouldn't be effective or efficient or cost-effective to use it to turn engines, because it costs more to make it than it does than the energy you would get out of it. So it's much better to burn coal or something and heat water.
But it is fun to use occasionally. Okay, thanks,
We've
Matt
seen that
Selen.
repeatedly.
And we'll be back for more physics fun later here on The Morning Show.